The average number of fast food meals consumed by young adults, people 18 through 24, decreased approximately linearly from 245 meals in 2006 to 192 meals in 2011. Determine the average rate of change of the annual number of fast food meals a young adult eats. What does that mean? Average rate of change.
Slope.
It happens to mean exactly the slope. But that's not usually the answer people give me. But that was a very good answer. Well, it says that the number of meals went from 245 down to 192.
So it'd be like how much it consistently dropped from 2006 to 2011.
Correct. So what they really want to know is, we started at 245 meals, we went down by 192. So what they want to know when they say average rate of change, they want to know how many meals did we go down each and every year. What we know is we went from 245 to 192, but that took how many years? 5 years. So if it took 5 years, how much did it go down every single year individually?
10.6.
And how did you figure that out?
You subtract 245 from 192 and then take the 53, which is your answer, and divide by 5.
Okay, so you took 245 minus 192, and you divided by
The difference between 2006 and 2011.
2006 minus 2011. You told me difference. Difference means subtract, right? Okay. What's 245 minus 192? That's 53. What's 2006 minus 2011? Negative 5. So you were very close in your answer. You didn't do the negative, correct. What's 53 divided by negative 5? Negative 10.6. All right, so why is it important here that our answer is negative? It's decreasing, yes.
I didn't say that.
He raised his hand politely. Everybody else just yelled it out. That was fine. Notice what we just did here. We took 245 minus 192. We took y2 minus y1. And then we took 2006 minus 2011. What's that?
X2 minus X1.
X2 minus x1. All right, so average rate of change is a fancy way of saying slope. So if you see a problem where they're asking you to find the average rate of change, all they really mean is slope. All right, so let's take a look at number 2. It says the number of skier/snowboarders visits to the U.S. slopes has increased approximately linearly from 57 million visits in 2005 to 61 million visits in 2011. Determine the average rate of change of the number of visits. So you see those words, average rate of change. That means they want you to find the slope. What you need to do is you need to decide what's x and what's y. So we've got two different kinds of things here. We've got 57 million visits. We've got the year 2005. 61 million visits, the year 2011. Which one's x and which one's y?
Year would be independent.
Year is the x. Y is year the x. It's time. It's always the x. Okay. So really what they've done here is they've told us we have the point 2005, comma, 57. In the year 2005, there were 57 million visitors. And they gave us the second point. The second point is
2011, 61.
2011, comma, 61. What's the answer? 2 over 3. Because you took 61 minus 57 divided by 2011 minus 2005. 61 minus 57 is?
4.
4 over 6, which you could reduce to be 2/3.
If you did put in a decimal answer for that, would be correct or not?
It would be correct, but I greatly prefer the fraction. When we're dealing with slope, fraction's a much better thing. Okay? Now, what does this slope tell us? What's the 2 and what's the 3?
Up 2 over right 3.
In a graph, it would be up 2 over 3. What does it mean in terms of skiers and years?
2 million every 3 years.
We get 2 million more skiers every 3 years. How do you know it's 2 million skiers every 3 years and not 2 years, 3 million skiers? Because of the way we put them. The Y's go on top, and the Y's were our number of skiers. So this means we get 2 million more skiers every 3 years. So what does this slope up here mean? Negative 10.6.
Means that the number of meals went down by 10.6.
Every year, right? Because this would be
What is it in?
over 1. No, it's not million. So
Oh,
this
just-
means,
okay.
so one young adult used to eat 245 fast meals a year, and it's dropped to 192 fast food meals in a year. That's just for one adult. So that's right. This would mean, on average, we drop 10.6 meals every year.
Is that true or something you made up?
I copied these problems out of the book, and in the book he did reference his data source.
That's a lot of fast food
Interesting.
meals.
Well, you gotta think you eat 3 times a day. That's what, 365 days in a year. That's almost 1,200. So it's not really a lot. Think about it.
Well, 245 would be almost one meal a day.
Yeah,
Yeah, that-
That's a lot of fast food meals.
that's
But of course, consider people 18 to 24. Where are most of the people who are 18 to 24?
Working at the said restaurant.
They're working at fast food restaurants, or they're at college. And what happens when you're at college?
You don't have any money or a mom to cook for you.
Right, so perhaps the cafeteria here, for example, would be considered fast food.
Oh,
So
that makes
A
me
lot of people don't
sad.
eat 3 meals a day, too. I know I don't.
a lot of people in college don't eat 3 meals a day either. That's
Only
true.
when I get
One.
6 or 7.
We go to practice at 9 o'clock at night. McDonald's.
Right, so you're short for time, you're rushed, you're short of money. Although McDonald's isn't that cheap anymore, really.
Now it's pretty expensive.
Dollar menu's good.
I was
though.
gonna say, now you can
Taco
get
Bell.
5 burgers. 5
Taco Bell.
Taco Bell, you can get the whole menu for like $10.
Hey, cans, best.
There you go.
I haven't eaten at a Taco Bell in a long time, although I like Taco Bell.
Good thing, you know, they just had the regular serving wine at Taco Bell now.
They started serving wine.
They started serving wine.
That's kind of a weird.
It's on the regular serving
Mexican food?
wine.
Interesting.
I remember
I mean, that
many-
sangria flavor.
many years ago, there were a handful of McDonald's selling McBeer.
Really?
But the national organization came in and said, no, you're not doing that anymore. So there were a few McDonald's that used to sell McBeer. It's called McBeer. All right, so enough McBeers. A person's annual salary increases $12,400 over an 8-year span. Determine the average rate of change of salary.
Would you divide that?
Yes, you just divide them. How come?
Because it says over. And it's like a, you know what I mean? Like, I don't know how to describe it.
Because the 12,400 has to go into the 8-year span.
Yeah, normally when we find slope, we do y2 minus y1. We find how much the y value changes, don't we? But they already told us the salary changed by 12,400. They already told us the y2 minus y1 in this problem. So you're right, this one's a real easy one. You just take 12,400 and you divide by the time, which is 8, and your answer is?
$1,550 per year.
So you're getting a $1,550 raise every year.
That must be nice.
That's a pretty good deal. That wouldn't be a bad raise. Questions on that one? All right, I want you to try number 4. I guess just number 4 for now. Okay, so what did you do for number 4?
Divide 5 by 5.
You divide 185 songs divided by 5 years. What means?
37 songs per year.
37 songs per year. Does this mean that the person downloaded exactly 37 songs every single year?
No, it's the average.
No, it's the average. Some years they might have downloaded 40, and another year they might have only downloaded 25, and another year so on and so forth. But on average, they download 37 songs a year. Questions on that? Okay. We got time for 5 and 6 maybe, then we'll have to go. This thing here says, if there is a linear relationship between quantities T and P depends on T, then the slope is equal to the rate of change. And we already said that before, didn't we? Slope is rate of change. Why did the book use T? I copied this directly out of the book, by the way. Why did they use T and P? T is time. P is people or percentage or population or whatever you want it to be. So P is the Y values here, and T is the X, because T is time, T is always X. Suppose that a quantity P depends on quantity T. So again, P is the Y and T is the X. If there is a linear relationship between T and P, then the rate of change of P with respect to T is constant. Fancy words, what are they saying?
Saying P doesn't change.
No, P does change,
But T doesn't
and T does change. They both change,
equally.
but they change equally.
Oh, okay.
That's like slope. That's exactly what they're saying. They're saying the slope is always the same. Okay, so here's what they mean. Let's look at number 4 here. It says 4 sets of points are described in the table. Decide whether there is a line that passes through them. So here's what you're supposed to notice. For set number 1, the X values are changing. They each go up by 1. But the Y values also change. They go up by 3. So does that form a line?
Yes. Yeah.
Yes, how come?
They're both changing.
The same. Constant.
They're both changing at the equal amount of space. So every time X goes up 1 value, Y goes up by 3 values. In fact, what's the slope there? 3 over 1 would be the slope, right? Y changes by 3, X changes by 1. How about the second set? Is that a line?
Yes.
Yes, the X's go up by 1. The Y's go
-4.
down by 4. So what would our slope be for that one?
-4, 1.
-4 over 1. Very good. How about set number 3? Is that one a line?
Yes.
Yes, because the X values are still going up by...
12.
The X values are going up by 1.
Oh, sorry.
You answered my next question. The Y values are going up by
12.
12. Does it matter that the X's don't start at 0 that time?
No.
No. Okay. Slope of that last one is? Sorry, slope of number 3 is? 12 over 1. How about the last one?
Yes.
Yes.
Yes, it's a line?
Horizontal.
It's a kind of boring line. It's a horizontal line because the X's go up by 1s each time. The Y's
Stays at 4.
stay at 4. So how much do the Y's change?
0.
0. So what's your slope?
0, 1.
0 over 1. All right, so I'm going to make up a set 5.
What is the slope of number 1 again?
The slope of number 1, the Y values go up by
1,
3.
1 over 3?
Nope, it's 3 over 1. Because remember, the slope is the Y values over the X values. All right, so let's make up one that is not a line. So one that's not a line would look like this. Maybe my X's go 1, 2, 3, 4. And my Y's go 5, 7, 10, 14. Why would that one not be a line?
not a constant rate change.
The x's went up by 1 each time, but the y's went up.
Different each time.
It went up by 2, then it went up by 3, then it went up by 4. Is that a line?
No.
No. So that's what something would look like that is not a line. You would not have a constant rise. But rise would change. All right, so the last question, we're supposed to fill in the table here. So we're supposed to assume that all of these are a line. So here we go, 0, 1, 2, 3, 4 on our x's. Our y's go 3, 8. What would the next one have to be?
13.
How come?
Up by 5.
It's going up by 5. So the next one's 13, then
18.
18, 23. Okay? Okay, did I do number 2 correctly?
Yes, sir.
Yes, sir. What did you have to do on number 2?
Subtract 7.
It will subtract 7 each time. All right, number 3 and 4 are kind of nice. What do you do on number 3? Yeah, what you really want to do first is find the slope. So what I would have done is I would have said m is, how do I find the slope?
31 minus 25.
31 minus 25 divided by
24 minus 21.
24 minus 21. That's 6 over 3, which is 2 over 1. So that tells me every time my x's go up by 1 step, my y's have to go up by 2. So the next one should be 27, 29, and then 33.
So what did you put? Below 31 minus 25, what? 24 minus 21?
24. Yeah, I took 31 minus 25. I subtracted the y numbers, and then divided by 24 minus 21. I subtracted the x numbers. And I think we're out of time, but to do problem 4, you would want to do exactly the same thing. Begin by finding your slope, and this time you're going to decrease by something each time. It will tell you what to decrease by. All right, we will finish this package up